So let's wait and
as well, and then you could have some background a path for this card to follow along with, and then we're going to make it follow the path, which is much more complicated than it seems. let's get started. So the first thing I want to do here is make a class for my computer car. So I'm going to say class computer car like that. It's going to inherit from abstract car. And then inside of here, I'm going to define for this car to follow along with. And then we're going to make it follow the path, which is much more complicated than it seems. Let's get started. So the first thing I want to do here is make a class for my computer car. So I'm going to say class computer car like that. It's going to inherit from abstract car. And then inside of here, I'm going to define the image for my car as well as the starting position. So I'm going to say image is equal to, and this will be the green car, and the starting position will be 150. Okay, that's pretty straightforward for the computer car. Next, I'm going to override the initialization. So I'm going to say define init self. This is going to be maxvel and rotation vel. Is giving me that. Very good. And then I'm also going to take in a path, which is going to be equal to an empty list by default. Then what I'm going to say is self dot, not self actually, super dot underscore underscore init underscore underscore, and I'm going to pass the max velocity and the rotation vel. What this is going to do is use this method right here to initialize all the values that I need, and then I'm just going to initialize a few more under here. I'm going to say self.path. Path is equal to path. Path is going to be a list of coordinates of points that I want my car to move to. And I'm going to say self.current underscore point is equal to 0 because I need to know what point in my path I'm currently at. Then I'm going to say self.vel is equal to the maximum velocity, because my computer car, we don't need to worry about acceleration. It's just going to immediately start at the maximum velocity, and we'll move at that speed the entire time. Okay, now we have the computer car. The next thing I want to do is just implement a method on this car. Now we have the computer car. The next thing I want to do is just implement a method on this car that can draw all of the points in the path, just because this will be useful for us to visualize. So I'm going to say define, draw points, and then I'm going to say self, and we'll take in a window. And I'm going to say for point in self dot path. I guess we could have called that points too, but that's fine. And then we'll say pygame dot draw dot circle, and we'll draw this on our window. We need to pass the color of our circle, which is going to be red. So in Pygame, the colors are RGB, so red, green, blue. So 255 is full red, 0 green, 0. blue. Then I'm going to pass the point. This is going to be the center of the circle that I want to draw. And then the radius will go with 5. So that means we're going to have a diameter of 10 for our circle. So that should draw all of the points for us. That's pretty straightforward. Okay, now we have draw points. Next, I want to make some feature that allows us to actually kind of click on the screen and, I guess, draw, create, select all of the points for our path. So that way we don't have to manually add them inside of this path variable. So you see what I mean in a second, but first let's create a car. Let's go computer underscore car is equal to computer car. We need to pass a maximum velocity and a rotation velocity. So for now, let's just go with 4, 4. We'll match our player, although we will reduce this later. And then for the path, we won't pass anything right now because we're going to kind of dynamically create the path. Okay, so now we've made computer car. Let's draw it. So let's pass computer car to our draw function, and then let's go to draw. Let's take in computer car, and let's do computer car dot draw, and inside of here let's draw on the window, and then what we will do is we will override the draw method in here. So we'll say define draw self win. We'll then say super dot draw. So we'll call the draw method from the abstract class here. So we'll do this. But before we do that, we will draw all the points. Or after, it doesn't really matter, but we'll draw all the points. So we'll say super dot draw. We need to pass the win, and then we'll say self dot draw points and the window. So now when we draw our computer, it will also draw all of the points in the path for this AI computer, whatever. Okay, there we go. Now that we have that, let's just run the code and see if the computer is being drawn, and then we will continue. Okay, great. So the computer car is there. That's all we were looking for. Okay, let me me clear the console here. Now let's continue. So the next thing I want to do is make it so we can click with the mouse, and that adds a point to our computer's path, and then we can get all of those points at the end of the program so we don't have to manually write them. This is pretty easy. I'm going to go inside of my event loop here. So for event in pygame.event.get, I'm going to say if event.type equals pygame dot. This is going to be mouse button down like that. And what we're going to do is get the position of the mouse. We're going to say pause is equal to pygame dot mouse dot get underscore. Or pause, and this will give us the XY coordinate of our mouse on the Pygame screen. Then we will say computer car dot path dot append position. So we'll add that position to the computer's path. Okay, that's really all we need to do, except at the end of our program, we're just going to print out path. Okay, that's really all we need to do, except at the end of our program, we're just going to print out the computer car dot path just so that we can copy it and then save it in our file and use it for future use. So let's run the code and let's see what we get here. Okay, we get our computer car. Now let's start adding some points. So I'm going to add one here, I'm going to add one here, and I will just add all of these, and then once I'm done, I will be right back. Okay, so I've added all of my points here. You can see this is kind of the path that I've defined. I've tried to spread them out as much as possible, but it doesn't really matter. I mean, just add the points and make them on the track, and you'll be good. You could put them off the track because we're not checking collision with the walls, but obviously the better you make your points, the better this is going to be. Now, I recommend you do spread them out a bit. If you make them too close, you're going to see it's going to look like all jittery when we're kind of turning and angling towards them. Anyways, that's fine. Okay, so let's close this, and notice when I close this, it prints out all the points. So what I'm going to do is copy all the points, and I'm just going to make a variable at the top of my program here called
Okay.
path. I'm going to do is That's fine. Okay, so let's close this. And notice when I close this, it prints out all the points. So what I'm going to do is copy all the points. And I'm just going to make a variable at the top of my program here called path. And I'm going to have it store all of these points, just so that I can use this with my computer, right? With my computer card. So now, what I will do is I will actually go to where I initialize my computer, and I will pass that path. So now that will be set for my computer. And I'm going to get rid of this mouse button down logic because I no longer... longer need that because my path has been set. So now that I have the path, let's just run this. And notice the path is still printing out. It's, saved, right? Because I have it in 838. Great. And then, of course, my red car can continue to move just like it did before. Awesome. So now that we have that, what I want to do is hop over to Paint. And I want to show you or discuss how we're actually going to kind of solve this problem of moving the computer car towards these points. And it's pretty complicated to do this, but I will try my best to explain. So let's say our target point is right here, and our computer is right here, okay? It's our computer car. So let's just go see, this is car. Now, the first thing that's kind of intuitive to do here is to draw a line between the top left-hand corner and the point that we want to get to. Now, we're going to be using the XY as the top left-hand corner of our car, so keep that in mind. That is pretty important for this. And anyways, there we go. So we have our target, and we have, our car. Now, how do we get to this point? Well, the first thing we can do is we can calculate the displacement in X and the displacement in Y, right? So we know the velocity, but we do not know the angle. And so what we're actually going to want to look for here is the angle between our computer and this point. If we know the angle, then we can tilt our car to that angle, and then we can move in that direction. Easier said than done, but that's the goal. We want to find the angle between our car and the point that we want to get to, and then we want to set the car so that it's facing that direction, and then just move the car in the same way that we moved our player car, because we already know how to move the player car, right? That part is done. We've implemented that logic. So anyways, we have X and we have Y. Now, we can easily calculate calculate x and y because we know the coordinates of this point and we know the coordinates of this point. We would just take this point's x, subtract by this point's x, that gives us the displacement in x. This point's y, subtract by this point's y, that gives us the displacement in y. Now, it doesn't really matter if we get negative or positive values. We could take the absolute value if we want, but it doesn't matter if we get negative or positive. Okay, finding the angle is still going to be the same. And then we have our velocity. Now, the velocity we don't really need to use, but we know the velocity is going to be the hypotenuse of the triangle. Okay, that's fine. So what we're trying to do here is determine the angle. We know x, y, and v, so there's multiple ways to do this. Now, remember, our equations are so, this is going to be an h, let me erase that, so, ka, and then toa. Now, in this case, it seems intuitive to me to use toa because we know the opposite and we know the adjacent. So what we can do if we want to solve for theta, which is the angle that we're looking for, is we can write the equation, tan, and then this is going to be of theta, is equal to O over A. Now, we can do our substitutions, and when we do our substitutions, we see that O is y, and that A is x. So we know x and y, those are two variables that we know. So now we want to solve for theta. So any of you that know trigonometry know that we have to take the inverse tangent of this, and then that will give us theta. So we can say theta is equal to, and then tan inverse of y over x. And then that will give us the angle that we're looking for. And in fact, this is actually always going to give us what's known as an acute angle. Now, an acute angle is any angle that's less than 90 degrees. Now, it will give us either a positive or negative acute angle, so we could get a negative value here or a positive value here. If we get a negative value here, that's indicating to us that we are looking to the left. If we get a positive value, then to the right. Anyways, that's not super important right now, but just keep in mind that this is how you calculate theta, and that this is always going to give us an acute angle. That is important. It's always going to give us something based on the way we're doing this calculation that is less than 90 degrees. Okay, so now we have found the angle. So we found the angle between our car and our point. So it should be simple enough, right? Just set the car at that angle. Well, it's not quite that simple. The reason why it's not quite that simple is because if our car is like facing this direction and we want to go over here, if I just set its angle to that, it's going to look like it's just teleporting over. That would be the easy solution. Just set the angle and then that'd be fine. But if we do that, what happens is, first of all, we're going to have our car facing the wrong direction a lot of times. We're also going to have the car flipping instantly, which we don't want. We want it to kind of slowly transition to that angle by its rotational velocity. We don't want it to just teleport over and face that direction. So now comes the problem. Okay, we know that angle. We know the angle our car is currently facing. How do we determine what direction to turn the car to get to that angle? That's really the problem now. We know the angle of our car. Now we just need to actually make this car get to that angle. So there's a few problems here. Again, the first problem is that we need to make sure we aren't just teleporting. So we have to kind of decide, do we want to go to the left or do we want to go to the right? Now, this might seem easy when you're looking at an angle like this, but there's so many different angles we could possibly have. And sometimes we could take the unoptimal approach if we only ever went to the left or only ever went to the right when trying to get to these angles. So for example, let's say we have this. Okay, let's just move this over a bit. Let's say our target angle is here. Okay, and our car is facing this way. So car is black and the target angle is red. Now, what way should we turn to get to this target angle? Well, we should turn this way. However, we might end up turning this way. So this is kind of the problem. We need to figure out which way to turn. Now, another problem that we're going to run into potentially here is that we might have the angle be here. So let's imagine this guy is gone, okay? We might have it be here. Now, theoretically, me turning like this is actually going to make it look like we have the same angle. I know this seems really weird, but the way that this angle is calculated means that this could actually be this, or other way around. We could get this angle from this. So we need to kind of put in some checks here to ensure that if we're actually moving downwards, we're actually going to go in the downward direction. We're not going to mistakenly calculate this angle. The reason why this is a problem is because these two angles are the same, right? If you look at this angle and you look at this angle, they're the same. And so when I do the tangent based on the way that I'm doing it, I could get this when my point is down here. And so I need to make sure that I'm actually looking at what direction my point is in, if it's lower or higher than where I am. And based on that, I'm going to need to make an adjustment to the angle I get to ensure that I'm going the right direction. So I'm just trying to kind of point out some of the problems that you can run into doing this. And there's all kinds of other problems as well. For example, right, like I was saying, we might go and try to go like this when instead it would be more efficient to go like this. So if we ever have a very large angle, we'll actually want to reduce that angle to a smaller yet equivalent angle so that we end up moving in the, I guess, best direction, the quickest direction to get to it. I also realized that all of my lights turned off here. I'm just going to turn them back on. I'm sure you guys can still see my face fine, but I have like these background lights that for some reason went off. Okay, so that's a bit better. Okay, anyways, that was kind of the point of this. I'm sure this hasn't cleared everything up. I haven't necessarily stated the solution. I just wanted to show you problems that can happen. And really the main problem is, what direction do we go? Do we go left or right? That's the main idea. So let's now start trying to implement this. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is Coding Interviews, Dave Tim, for a moving, I need to move towards a point. So now this move method is special because when I'm moving, I need to move towards a point. So the first thing I need to do is angle the car in the correct direction. And if I am in the correct direction, then I can start moving towards that point. And we already know how to move. We can just use the move method that we have inside of here, right? If we're angled in the right direction and we're going by a static velocity, then that's fine. So I need to look at my other code here because it's very easy to mess this up. So inside of move, what I'm going to do is just make sure that we have a point to move to. I'm going to say if the self.current point is greater than or equal to the len of self.path, then I'm going to return. This is just going to ensure